My seminar topic is Millimeter Wave Communication Technology and its Applications. Myself, I am Nayana Manoj. I am from S7 ECA and my seminar is guided by Assistant Professor Joni M. George, Department of Electronics and Communication. Moving to the contents, these are the main contents I go into this presentation with this slide. First one is introduction of millimeter wave, and next is moving to what this is an introduction of the what is a millimeter wave, and next one is history of millimeter wave. Next one is how does a millimeter wave work, like generation, its propagation, etc. And next one is the classification. Classification is based on the frequencies and also the importance of the millimeter wave and the parameters, the advantages, the disadvantages, and the major companies that uses the millimeter wave technologies and application, conclusion, and reference. These are the main contents we going through this presentation and moving to the introduction. In introduction, the rapid increase of mobile data and the use of smartphones created an unprecedented challenge for wireless service providers to overcome the global bandwidth shortage. Millimeter wave communication technology is a wireless communication technology that uses high frequency electromagnetic waves in the range of 30 GHz to 300 GHz. In case of the fifth generation of cellular networks, it utilizes the variety of frequency bands. The one of the frequency band is the millimeter wave. In the millimeter wave ranges from 30 GHz to 300 GHz, but in the case of 5G, it uses only the 24 to 100 GHz range of the millimeter wave. The high frequency of the millimeter wave, it can carry an incredible amount of data. And moving to what's a millimeter wave. Millimeter wave is a part of electromagnetic spectrum. Due to high frequency, it has short wavelength. The wavelength that typically measuring between 1 millimeter to 10 millimeter, so it is called millimeter wave. So this technology is also known as millimeter wave communication technology. Also, the millimeter wave, it's a type of electromagnetic radiation. Due to high frequency, these signals have a short range. The range is depends on some of the factors like its frequency, the environmental factors. According to the factors, it has ranges. In the case of outdoor, it from 100 meter to 500 meter. In the case of indoor, it ranges from 30 meter to 100 meter. In the case of line of sight communication, it ranges from few kilometers. Also, it used in 5G cellular networks. It can provide faster internet and lower latency. Latency is below the 1 millisecond. And this is the frequency spectrum. The millimeter wave region is situated in between the microwave region and terahertz region. The microwave, it is ranges from 3 to 30 gigahertz, and terahertz is ranges from 1.1 to 30 terahertz hertz. And millimeter wave is between the microwave and terahertz region. Next is moving to the history. In history, the discovery of the millimeter wave that is running in between 1894 to 1896. The first discovery of the millimeter wave can be traced by the Indian physicist J.C. Bose. He successfully transmitted and received the electromagnetic waves with the frequency of 60 GHz over a distance of 23 meters. After the tracing and discovery of the millimeter wave in the early 20th century, the J.C. Bose also demonstrate the use of millimeter wave to transmit signals over short distance. In 1938, the Gustav Hertz and Heinrich Rush developed the first millimeter wave radar system. In 1950, the millimeter waves are used in satellite communication because it has carry an incredible amount of data, so it's mainly used in satellite communication. In between the 1960 to 1918 period, the millimeter waves are used to develop new high-speed wireless communication systems. And also it used for the development of the new imaging and security systems. In 1997, the first millimeter wave security scanner is developed. In 2003, the first millimeter wave medical imaging system that developed by the Siemens AG. And moving to the 2010, the 5G technology development included the exploration of millimeter wave frequencies for both enhanced mobile broadband, enabling multi-gigabit per second data rates. In 2016, the first millimeter wave 5G smartphones are released by Samsung. Samsung is one of the major companies that use the millimeter wave communication technology. In 2020's and present situation, there is a continued expansion and optimization of millimeter wave technology for both 5G and emerging wireless communication standards, as well as the application in areas like automotive radar and industrial sensing. Also, is used in this technology is mainly used for the research applications. And moving to the working, how does a millimeter wave work? The first one is generation of a millimeter wave. The generation, it mainly depends on the based on its applications. So based on the applications, mainly three type of methods are used for generally the generation of the millimeter wave. First one is optical heterodyne beat frequency. Next one is direct microwave to millimeter wave frequency multiplication. And third one is solid state devices. First one is optical heterodyne beat frequency. Optical heterodyne beat frequency in this method, which use two lasers with different frequencies to generate a beat signal whose frequency is equal to the difference of two laser frequencies. The beat signal can then be amplified and transmitted as a millimeter wave signal. So, according to this method, it mainly used for the high performance application such as satellite communications and radar. And the second method is direct microwave to millimeter wave frequency multiplication. In this method, it uses nonlinear devices. The nonlinear devices means that its input and output is not proportional, it's in proportional. So, the in nonlinear devices mainly used in diodes and transistors. These are some of the example of nonlinear devices, and these devices used in direct microwave to millimeter wave frequency multiplication method. In this method, there is a multiplying the frequency of a microwave signal to generate the millimeter wave signal, and this method is mainly used for lower cost applications such as 5G cellular networks and radar, automotive radar. The third method is solid state devices. The solid state devices, it mainly include the gun diode impact diodes, and in this method it can directly generate the millimeter waves. However, these devices are not very efficient. So the solid state devices are mainly used as applications such as portable radar and imaging systems. Next one, after the generation of the millimeter wave, next one is the propagation. Moving to the propagation of the millimeter wave signals have relatively short wavelength, so they behave different from low frequency signals. The low frequency signals in the means of it has the frequency range that below the 300 Hz. So these waves are more susceptible to attenuation and are easily absorbed by atmospheric gases and objects in their path. So the millimeter waves that result in shorter effective transmission distance. Third one is antenna arrays. Due to challenges in the propagation, the millimeter wave communication systems often employ antenna arrays. Antenna arrays means that there is a group of antennas present and this is connected together. So it's called antenna arrays, and these antenna arrays are mainly used for the beamforming purposes. Beamforming means that it is the technique that focuses the signal energy in a specific direction, that effectively increasing the signal strength and quality in that direction, and also it compensating for the signal susceptibility to obstacles and attenuation. After the antenna arrays implementation, it's moved to the line of sight communication. The line of sight communication, the millimeter waves often used in line of sight communication. According to line of sight communication, there is the presence of a transmitter and receiver. So, in between the transmitter and receiver, there is a direct and unobstructed path between them. According to this figure, we also see that there is a transmitting and there is a receiving antennas also present in there. But in between these transmitting and the receiving antennas, there is an unobstructed and direct path. So this is the line of sight communication. So the line of sight communication is essentially for maintaining and is mainly used for maintaining or improve the quality and reliability of the millimeter wavelengths. Next one is based on the classification. The classification of the millimeter wave. This classification is mainly based on the frequency. we all know that the millimeter wave has the frequency ranges from 30 gigahertz to 300 gigahertz. So it has based on the frequency, it has divided into three types: low millimeter wave, mid millimeter wave, and high millimeter wave. Moving to low millimeter wave. The low millimeter wave, it has the frequency ranges from 30 gigahertz to 60 gigahertz. It mainly used in the applications like short range wireless communication, automotive radar, and some 5G deployments. In mid millimeter wave, it has the frequency ranges from 60 gigahertz to 100 gigahertz. It utilized for applications such as high speed wireless data transmission and point to point communication links. Next one is high millimeter wave. It has the frequency ranges from 100 gigahertz to 300 gigahertz. It includes the upper millimeter wave range, and it's often used for specialized applications including advanced imaging systems, security scanners, and certain scientific research applications. So the high millimeter waves are mainly used for the research applications. Next one is, this is the basic classification or a comparison between the microwaves and millimeter wave. The both waves are existing. So according to the comparison, the millimeter wave have a frequency ranges from 30 gigahertz to 300 gigahertz. It has high frequency range. But compared to microwaves, microwave have low frequency range. It ranges from 3 gigahertz to 30 gigahertz. In moving to the penetration capabilities, the millimeter wave have limited penetration capabilities because it cannot be penetrated through the solid or non-solid obstacles. But in the case of the microwaves, it can penetrate through the solid or non-solid obstacles such as like the trees, buildings, etc. And moving to the wavelength, due to high frequency of the millimeter wave, it has typically short wavelength. It is mainly measured from 1 millimeter to 10 millimeter. But in the case of the microwave, compared to my millimeter wave, it has the short wavelength. So short frequency. So it has a short wavelength that ranges from 1 millimeter to 30 centimeters. This is the several factors like frequency, penetration, and wavelength factors based comparison between the millimeter wave and microwave. And moving to the importance. Moving to the importance of the millimeter wave. First one is high data rate. The millimeter wave frequencies offer significantly higher data rates compared to lower frequency bands like 4G. 5G is a lower frequency band and it has the frequency ranges from 450 MHz to 3.8 GHz. This makes the millimeter wave essential for meeting the growing demand for data intensive applications such as the high definition video streaming, virtual reality, and augmented realities. After high data rate, the next one is the importance 5G network deployment. The millimeter waves that plays an important role in the deployment of 5G network. The millimeter wave frequencies are employed in densely populated urban areas to provide extremely high-speed connectivity. The low latency, the high capacity features are the integral of 5G technology, and the millimeter wave have an important role in the case of 5G network deployment. Next one is low latency. Low latency means that the millimeter wave technology that can enable ultra low latency communication because there is no delay in between the transferring of the data and or less delay in compared to other frequency bands or other waves. In millimeter wave it has an especially it has an importance because it has the low latency and which is mainly crucial for the applications such as autonomous vehicles, remote surgery, and real-time industrial automation. Next one is emerging technologies. The millimeter wave is at the forefront of emerging technologies such as 6G and beyond, which will continue to push the boundaries of wireless communication with even higher. So, not only the 5G, it also used in 6G because according to the millimeter wave, it has frequency ranges from 30 gigahertz to 300 gigahertz. In between this frequency, the 75 gigahertz to 100 gigahertz range is used for the 6G applications. Next one is short range communication. The millimeter wave has high frequency range, so it has a short wavelength and it also used for short range applications. The millimeter wave is employed for short-range wireless communication technologies. These technologies enables high-speed data transfer within homes and offices, enhancing the performance of wireless networks. Next one is satellite communication. Moving to satellite communication, the millimeter waves are widely used because it can transmit a large amount of data at the same time. The millimeter wave frequencies are utilized in satellite communication for their ability to deliver high data rates and reliable connections. They play a crucial role in broadcasting. Broadcasting means that high internet speed connection, internet services, and remote sensing applications via satellite. And moving to this graph, we can see that there is a part of microwave communication and millimeter wave communication. Millimeter wave is situated in between the microwave and the terahertz regions, and in between the 20 GHz to 100 GHz frequency band is used for the satellite communication purposes. Next importance is wireless backhaul. In millimeter wave technology that used for wireless backhaul links in cellular networks. It is the use of wireless communication systems to transport the data between the internet and sub-networks. It can help an organization or a mobile network to eliminate the physical cabling. So the wireless backhaul have an important role in cellular the networks because it can connect or transport the data between a major network to the minor networks. Next one is parameters affected by millimeter wave. There are several factors or parameters that affected the millimeter waves. The first one is propagation distance. Propagation distance means that the millimeter wave signals have limited propagation range due to its high frequency range. So compared to other lower frequency bands, they are often used for short-range communications due to their susceptibility to attenuation and signal absorption by atmospheric gases, rain, and other environmental factors. The effective propagation distance is influenced by the frequency used and the specific environment. Next one is obstacle penetration. The obstacle penetration means that millimeter wave signals have limited ability to penetrate the solid objects because they are absorbed by atmospheric gases like walls and buildings. In this limits their indoor coverage. So the obstacle penetration means that due to the millimeter wave, it has less propagation, it has less wavelength. So due to the less short wavelength, it has ranges from short distance. So also it absorbed by the atmospheric gases and other obstacles, so it also limited its indoor coverage. Next one is the noise figure. Noise figure of a millimeter wave receiver is a measure of how much noise is added to the signal during the reception. Due to the noise figure, the lower noise figure results its better signal to noise ratio and improve the system's performance. The power consumption, the millimeter wave systems that typically consume more power than lower frequency radio systems. This is because the millimeter wave circuits are more complex and it requires higher power levels to transmit and receive the signals. Next one is due to the high power consumption, the millimeter wave design. Millimeter wave communication technology based circuits or design purposes that all are costly. Next one is antenna design and beamforming. The design of millimeter wave antennas and the use of beamforming technique are critical to focus the signal in the desired direction. The beamforming helping mitigate signal attenuation, interference, improving link quality. The antenna design and beamforming, the mainly using antenna arrays. Antenna arrays means that this group of antennas that connected together for the beamforming purpose. In beamforming, it mainly focuses on a signal in a specific direction. And moving to the advantages, the millimeter wave have some of the advantages like larger bandwidth. The bandwidth is maximum up to 100 gigahertz. Next one is higher spatial resolution. Next one is a shorter wavelength. The wavelength is typically measuring from 1 millimeter to 10 millimeter wave. And next one is higher data transmission rate. The data transmission rate is more than 10 gigabit per second. Moving to some of the disadvantages, also see that the millimeter wave have the higher power consumption because its circuits are more complex, so it leads to higher cost in manufacturing. Next one is the millimeter waves are not applicable for long distance applications due to its high frequency and its short wavelength. Next one is the line of sight requirement. Next one is the companies. These are some of the major companies that uses the millimeter wave communication technology. The Qualcomm, Intel, Nokia, Skilu, and Samsung. Like Qualcomm and Skilu, Intel, they all are focused mainly the production of the millimeter wave chips. These chips mainly used for the measuring the millimeter wave frequencies, and the Samsung, Nokia, these are the main sellers of smartphones. So they release the Samsung is the first Samsung releases the first millimeter wave technology based smartphone. So these are some of the main companies that use the technology. And moving to application. In application, first one is small cells deployment. The small cells deployment means that the small cells are the low powered cellular base stations that have ranges of 10 meter to few kilometers. They are used to improve the coverage and capacity in area where the macro cells are not enough, such as dense urban area, indoor spaces, and rural areas. The small cells can be deployed indoors or outdoors, and they can be mounted on poles, buildings, or other structures. It can help to reduce the interference between the millimeter wave networks and other radio systems. This is because the millimeter wave have the good directivity, and which means that they can be focused in narrow beams to reduce interference with other networks. In small cell deployment, the small cells are the low power cellular base stations, and the micro cells means that these are the high power cellular base stations. So mainly these small cells are deployed for to improve or the coverage and the strength of the signal where the macro cells are not enough or absent. And also the small cells which help to reduce the interference between millimeter wave networks and other radio systems. And also the millimeter may have a good directivity because it mainly focus a small portion of the electromagnetic spectrum, so it can good directivity, and it can reduce the interference with other networks. So this is a sample diagram or a representation of the small cells. We can see that there is the presence of the cellular base stations, and but its ranges from the small distance like 10 meters to up to few kilometers. And moving to the next application is the wireless backhaul. The millimeter wave technology is used for wireless backhaul links in cellular networks. It is the use of wireless communication systems to transport the data between internet and subnetworks. So these wireless backhauls that connect the cellular networks for the transporting data between internet and subnetworks, and it can help an organization or a mobile network to eliminate the physical cabling, and it's also less expensive one. Also it has a faster deployment. The next one is the point to point links. In the case of the millimeter wave communication technology, the point to point links is one of the major application. It mainly used to transmit the data between two fixed location. The two fixed location means that there's a two building inside the campus or two cell towers in the mobile network. So, in this case, it is the data transmission between the one of the two fixed locations. The millimeter waves are well suited for the point-to-point link because they offer a number of advantages, including high data rate. The data rate is greater than the 10 gigabit per second, and low latency and high speed. The next one is 5G wireless communication. The 5G wireless communication means that in 5G, the millimeter wave have an important role. The millimeter waves frequencies are a critical component of 5G networks. They enable ultra high speed wireless data transmission, low latency, and that has the ability to support a massive number of connected devices, and also it can carry a large amount of data at the same time. This makes the millimeter wave crucial for the applications like high-definition video streaming, augmented reality, the virtual reality, and IoT connectivity. So the AR, VR, these are the some of the leading technologies in this era. So the millimeter wave have an important role in this type of tech, technologies. And 5G is the fifth generation of cellular network. It's also a wireless technology. It is expected to revolutionize the way we use the wireless devices and networks. And moving to fixed wireless access, before that, the wireless backhaul, it have one of the example is consider a bank has a bank which has some of a lot of minor branches and there is a major branch. So the employees present in the major branch and the employees present in the minor branch also they have same requirements provided by the bank. So according to wireless backhaul is present. Wireless backhaul means that it can transport it can carry a data from its major network to minor networks without any failure. And moving to fixed wireless access, the fixed wireless access it mainly used to provide a broadband internet access to residential homes and businesses, especially in areas where traditional wired broadband options are limited or costly to deploy. The fixed wireless access connects individual premises to the internet via wireless links. In online gaming, the one of the example of the fixed wireless access in online gamers which require a low latency connection to ensure smooth and lag-free gaming experience. The fixed wireless access it can provide the necessary speed and low latency for online gaming. In one of the example of the fixed wireless, it mainly one of the great thing it mainly provide a broadband or high-speed internet connection in the residential homes and business where the traditional broadband options are limited or costly. In one of the example, in a rural area, there is the not presence of a wired broadband options or there is no a broadband connection. They can the internet service providers they can provide the fixed wireless access to them and they fix an antenna in their house and this antenna is connected to the major antenna site and it can it can carry a large and this connected to that antenna and the signals from the major antenna is received from this antenna and there is a modem that's present in the house and they can access the um, broadband connection. So these are some of the main applications of millimeter wave: the small cell deployment, the wireless backhaul, the point-to-point links, the 5G wireless communication, and fixed wireless access. And moving to the conclusion, in millimeter wave communication technology, it's a promising wireless communication technology that operates at very high frequency, the frequency that ranges from 30 to 300 gigahertz, and also it allowing for extremely high data rate. The data rate is greater than 10 gigabit per second and support for large number of devices simultaneously. Also, the millimeter wave communication technology have some of the limitations such as shorter range and susceptibility to signal blockage. These challenges overcome with careful planning and design of millimeter wave systems. And also the millimeter wave technology, it has an important role in 5G cellular networks, high-speed wireless broadband and virtual and augmented reality. So, in according to the millimeter wave technology, some of the limitations after the limitations are just the short range and susceptibility to signal blockage. These challenges overcome with careful planning and design of millimeter wave systems, and the millimeter wave have the higher frequency range and short wavelength. Due to this short wavelength, it only used for the short range communications. So with the concern of overcome planning, careful planning and designing of the millimeter wave systems, we can overcome this type of the limitations. And millimeter wave communication technology is obviously a future technology that helpful for the data transmission and the wireless communication field. And these are the some of the references I referred for my seminar work. And thank you.